Okay, thank you very much. So welcome everybody. Thanks for being here for this section. We are going to talk about an implementation that is going to deal with a single sign-on with Azure AD and also B2C with using certificates and also using Azure Key Vault connecting to a Drupal application. And those who want to follow up, there is a link here below this screen that leads to a folder where you can download the PDF for this presentation. So there are just a few seconds. So if you want to copy and access this one. Okay, just moving forward here. So about our agenda today, my presentation for myself, the demands that we had for this project, the research that we needed to do, the choices that we had by that time, the solutions that we got, and what's for the future regarding this implementation, and also opening for questions that you may have along the way. So who am I? I'm currently a tech lead at Northern Commerce. It's a digital agency. We deal with CMS and also e-commerce. And I've been working with Drupal since 2019 and learning a lot since then with a few challenges along the way and liking it and enjoying it very much, as well as all this big community. And I also like Star Trek and Star Wars, but some think it's impossible to like both, but I do. And yeah, sorry for the one who don't like both. This is me. I also practice and teach Kung Fu on my free time. I like reading, traveling, and cooking. And I also like a good challenge that was this project that we are going to talk about. So next demands, we had a client with a project already live, and we're doing some modifications for this client. And they were looking for not allowing the local login anymore. They wanted to use their solution that used third-party authentication and using for this the Azure B2C. Okay, so we needed to implement this and avoid the local login while we still had like a backdoor for local implementation, local administration of the Drupal application itself, in case we couldn't log with the B2C feature. So we did some research about how it worked because we are not very familiar with this kind of implementation, integration with Drupal. And basically the Azure B2C, it allows us to make a registration process, like receiving the user info, so we can have a sign-up form, for example, on our application, in Drupal in this case, and we can create a user and registering these with Azure B2C. There's another option as well that we can have third-party service, like, for example, Facebook or LinkedIn or Salesforce or even a custom application, and we can integrate this with B2C and then have, in this case, the Drupal connecting with B2C to get this information of the users there, the registered there. So Azure, it's like a middleman that ensures that the user is who they say they are. So there's a difference, and we learned about that between Azure AD, the Active Directory, and the B2C, the business to customer, and that we can build a relationship with the user, so we can build like custom fields like name and favorite things that this customer wants, or birthday, and what else we need in terms of information of the user. And Azure AD will keep this in the history. And also we can build some policies like roles and things and tiers of authentication that we can build in this login process. So B2C is a more complete and customized experience than the Azure Active Directory. And in this example here, we have our application on the left. Okay, so we can request a sign-in to the Azure B2C, and then Azure B2C will also authenticate with another application. In this example, we have Salesforce that will authenticate the user and go back to Azure B2C that will communicate with our Drupal application and say, okay, this user is okay to go. This is our identification for this user. So in terms of our Drupal application, we had some choices here. We need to know which choices we had. And one that was already implemented there, but not used yet, was the OpenID Connect contribute module. And for this contribute module, we had a few add-ons, a few plugins to add to it. And one of them was for the Azure AD, the Windows, the Microsoft Azure AD. It was not B2C, but we are going to talk about this a little later in the presentation. So some challenges for this project that the client presented us. One of them was that OpenID Connect, this contribute module, was not prepared to use a certificate, just secrets. And secrets were like plain passwords, plain text passwords. And the client needed us to implement this using certificates and not secrets, because the secrets could not be available anywhere there. They needed to change it from time to time. In this case, it's 6 months they needed to change it. So we needed to implement this using some certificates. It was basically some signed pair of public key and private keys. It was basically that. So the client wouldn't be able to use secrets, those certificates for B2C, and this was to comply with their security measures and security protocols for all the systems that were available in the web, the internet. Azure B2C also doesn't provide support for connections with certificates. So we need to use Azure B2C, not AD, but B2C was not able to make the protocol, the connection using certificates, only secrets. That would not comply with the requirements that we have from the client. We also couldn't access the client's environment. So we couldn't access their system that they use it for registering users and managing users. And we also couldn't access their Azure B2C environment. So we would need to solve this one because we need to make some developments and test it. And the test could not be made from our environment, only with their environment, just inside their VPN. And we couldn't access their VPN. And also the credentials, in this case, the certificates and the keys and passphrase and passwords could not be stored in a place accessed from the web. So for example, in this case, we were using Acquia, and we couldn't store it in the doc.root folder, for example. It should be somewhere above doc.root that would not be accessible through the web. This was also to comply with their security measures. Okay, so in terms of solutions, we were already going with the OpenID Connect contribute module. So we had two options to choose from. One of them would be to make a custom module, but based on the the solutions already implemented by the module, or just modify the contrib module and then submit patches for a possible future implementation, future release. Okay. And by that time, we chose to use the contrib module as it was, and because at the beginning we thought it would be just a simple implementations with a few modifications, and they could be applied easily with a patch. Yeah, which was not the case that we figured out later. So in the original configuration for the Azure, for the connection, the plugin to the Azure AD module for the OpenAD Connect, we had some configurations that we need to do. One of them was the redirect URL, because first we call Azure, we identify that we want to connect to a certain app using this client ID. And then Azure just makes a callback, checks if this app exists, check if we are calling from authorized location, and also gives a callback to the address that we are setting here. So the module automatically set up the base key URL and all the rest that we need for this callback. And also, in this case, the secret generating from the Azure application. So on the Azure environment, we can, for each client ID, generate a secret. And we copy that secret to our applications in order to send it at the proper time. So the first thing we needed to modify was in the module was for it to accept the use of an X509 certificate instead of using that secret. So the field for the secret would be hidden, and we would have some options to use that. And these options, we would use some variables. We have some environment variables to store the path for the certificates and the passphrase. That was what we implemented there. So in this process, now using how it would be with using a secret, we just make an authorization request to Azure using our client ID. And then, in this case, for Azure AD, that we were testing with that, just makes the callback with an authorization code. And then we get this authorization code, we will build a token, JWT token, using this authorization code and other parameters there. And then we build a payload in this token and goes back to Azure AD. And then Azure AD authenticates everything, it's okay. Then it comes back with the credentials from the user. There is some things happening here under the hood. In fact, Azure AD will connect to whatever custom application that is connected to it to just authenticate the user, like placing a customized login screen. The user will fill their data or simply sign up, depending on the policy. And then we have only the OID, that is the credentials, the identification for this user that is stored on Azure. And then we can begin dealing with this token on our application. So what we need to make this request to Azure, okay? Again, still using a secret. We need these parameters here. We have the code, the authorization code that we received from the first request. Then we have the client ID that we connect to the correct app on Azure. The secret that we have stored on our application beforehand. The redirect URI, just to confirm that we are who we are saying we are. And the grant type, that is a string, that is just saying authorization code. So all this is built inside this, the file, this window aad.php, that is used as a controller inside the module, the control module. So the response that we have, we get from this token to the post to the endpoints that we can get from the Azure environment. And then the data will come from the body that we get in this response in case it's successful. And then we're going to retrieve from the token the response data with the IDs that we need for our application. Also refresh token in case we need to communicate again with Azure. Okay, and basically that will be it for this application. So the difference here between the secret and the certificate, using a secret or a certificate, is that we need to change two parameters there. So instead of this client secret here, on the third parameter, client secret, we are going to replace it with the two parameters. One will be the client assertion type, and it will have a fixed string saying exactly that's what in the screen, and also a client assertion that will have a token that we will need to build in order to request this and to request an authentication using a certificate. And this is the key, and this was the real challenge in this implementation, to build this token correctly. So to build this token, we will need three parts: the header, payload, and a signature. Okay, so the payload we will build like it's in the screen with the endpoint there, the point for the token. We have two endpoints that Azure provides us. One with for authorization. There's the first request, another one to retrieve the tokens. An expiration time that here is set for 10 hours. The client ID. This JTI is just any random unique number that you can generate by the time that we are generating the request. The current time, and again, the client ID. We need to repeat it. So we get this payload, we apply a base 64 URL encoding to it, and then we have this piece of the token that will be the payload. Besides that, we need to build also the header that will have just the algorithm that we are using, the RS256, the type of the token that we are sending, in this case the JWT, and a parameter is called X5T. And that was a challenging one to build the correct one that Azure could identify correctly. So we get all this header, and we also authenticate with a base 64 URL encoding. And now we're going to talk about this X5T there. So the X5T, we need to get a fingerprint, an X hexadecimal dump from the certificate that we are using to authenticate. And it is a SHA-1 fingerprint. Then we convert this X code to a binary code, and then we apply a base 64 encoding. And this is the key in order to Azure to correctly identify this certificate. Otherwise, it will not. And this was difficult to find because on Azure, I don't know now, but at the time, it was not exactly there was not a specific data about how to encode this X5T there on Azure documentation. So we had to research this and found a forum and could make this implementation work. And then at least we will have the signature. So the signature, we use this method here from OpenSSL, using PHP, of course. And then we need the header and the payload with this dot there. And the signature, there's a variable that we will have then after we apply this method. And the private key that was generated together with the public key that was signed and made in the certificate, and the kind of encryption that we are using. So we get all this, and we also base64 URL encode this information. Then the token, we will have just concatenating all of this with those dots between each part. Also, we have this, the private key. As I said, the private key was being stored on a folder above .root. And so we get this path from the environment variable, like it is in this code. Then we could retrieve the private key with a passphrase, okay, from this location. The passphrase is not mandatory, but in case we don't have a passphrase, we need to use this parameter as null, not empty. Empty will give us some errors. So when we send this token to Azure, then it sends us back, in case it's everything all right, it sends us back another JWT token, and we use two methods to get information that we are going to need in the application. And one of them will be the decode ID token, and the other one will be the retrieve user info. Okay, so we are going to get these two pieces of information there that will be useful for our implementation here. So this is the face of the token that we can. We have a feature, an application inside this website, the jwt.io. So we can test and see if the token that we are getting is correctly formatted and what we can retrieve from it. So in this case, using this application, we have the header, that we have something very similar to what we sent to Azure at the first place. We'll have the payload itself, so it will have the origin of our response, that will have some client information there. And also we'll have the OID. The OID will be the unique identification for the user that is authenticating in this case. Okay, and also we'll have some custom information, like this one that brings the emails. In our case, for our application, we were using also the emails to first match the user that was coming to the application, or either to create a new user on Drupal, or to match with another already existing user there. So we could get this match about the emails and just add information about the OID. And in this case, with the information of the OID on the user profile, we could faster authenticate on the next times. And finally, in this application, we can have also the signature. And here we can get our private key. We just paste here. It doesn't store anything there. We just paste here to authenticate the token that is coming from Azure. Okay. So what we retrieve from the token, we decode it, and then we can get this information from the OID and the custom data. We're using the methods that are already there in the OpenID Connect config module. So talking back to our challenges here, we could solve the fact that OpenID was not prepared to use certificates, so we could implement these on the config form of the OpenID Connect, and also test and make everything work using certificates, but still with Azure AD. We need to test this and make sure it worked correctly with our environment, then test with the client's environment. So we needed to publish everything to the storage environment so that they could test everything there. And okay, it's okay, the connection works. Now we can proceed to the other parts, the other challenges here. Some solutions for the other parts. So as I said, Azure B2C that we needed to use, in fact, used only secrets. It was not prepared to use certificates, and we needed to clear this with Azure support, because we were not finding anything about using certificates with B2C. and in fact it was not working when we tried. So we need to make sure, and they told us that they were only using secrets, not certificates. So we needed to come to another solution for that, because using secrets would not comply with the client's requirements in terms of security for the network. So we came to the solution to use Azure Key Vault. And with Azure Key Vault, we would be able to use a secret. The client's requirements were about the connection to B2C, not with Key Vault that they were already using there. So we could make an authentication with Azure Key Vault, get the secret for the B2C application, use this secret with that same connection that we saw before in this presentation, and make the connection with B2C. B2C authenticates the user and gives back the information that we need, that the user is authenticated, it is okay to go, and they write the information from that user. And to connect to Azure Key Vault, we needed to use Azure AD. So we needed to make an authentication request to Azure AD, and once approved from all this process that we explained earlier with the certificate, then we had this approved, and we can connect to Azure Key Vault. So we got all this information that we had there to authenticate with the certificate, and using Azure AD to authenticate to Azure Key Vault. Then with this approval, we then made a request to Azure Key Vault to get the secret. With the secret, we make the request to Azure B2C, and we get the user info in case everything is approved in terms of authentication. So this is a longer path to get this authentication, but this would comply with the client's needs in terms of security. And that's because each 6 months, in that case, they were changing that secret. So they changed it on Azure Key Vault, and they changed it on B2C. So whatever secret we got from Azure Key Vault, it was transparent for our Drupal application. Regardless which secret it was, we just got the secret and implemented on the request to B2C. We couldn't store this secret anywhere on our application or any variable, any configuration variable there. So to get the secret here, the secret itself, once everything is authenticated, we just needed to make a curl request using that access token there that we built before, using to request the secret from the Azure Key Vault. And the secret just came from the body of the response from Azure Key Vault. Okay, the only difference on connecting to the Azure AD that was connected to Azure Key Vault was this grant type that we needed to change to client credentials. And the other things we needed was always all the same. We were using certificates to connect to Azure Key Vault. So it was all right. We just needed to change this grant type there to client credentials. And after that, we could get the key itself, because the process was all the same. We just needed to make a next request to get the key that was posted to this address there. We had a special URL to make this request with Azure Key Vault, and then we just got from the body the access token that would have the secret there. So this is the modification that we needed to do in the config module, also to add this option to use Azure Key Vault, not only certificates. So we needed the URL for the Azure Key Vault, the authentication token address URL to request the token to authenticate, and the client ID there is different from the client ID for B2C. And the other things would be the API version and the API version number for this authentication request for the protocol. So Regarding the challenges, so we now have the OpenID Connect was prepared to use certificates, and now we could use secrets, but the secret would not be stored on our application, so it complied with the client's requests. And also to solve the fact that Azure B2C doesn't use certificates for authentication. We are going to go around and connect to Azure Key Vault. So two other challenges that were still there: no access to the client's environment, and the credentials could be stored in a place not accessible through the web. So in terms of, we already said this, and in fact it was a spoiler, and we had the environmental variables in this case on Acquia. So what we had in these variables were just the path that was above the doc root in this case. If it was like an Pantheon, would be web, or any other custom application could be any other name for this root directory for Drupal. So here we had certificate path and the private key path stored here. So whenever we needed to change this path to another place, we could. We just needed to change here, or for example, change the name of the certificate or something like that. We could change it also here with the path for this file. So to make this not accessible from the web was solved as well, and the client's access to the client's environment we didn't exactly solve because it was out of our hands in this case. So in this case, we just needed to create another Azure B2C environment for our company, our agents, and we used these to test. And we made some calls with the client to try to make sure that our environment would be set almost exactly like theirs. So the policies and everything else, not all the data for the users, we didn't need everything like that, just the email. But everything else we needed to set exactly as they had there. And we also didn't have access to the application that they used to really sign up their users and log in their users. We didn't have access to this one, even to look at it. So we were kind of blind in terms of how to thorough test everything. But we needed to use that test with our environment, then save to the stage environment so that they could be able to test this as well. So all the challenges were solved by them in this case, and after a longer time that we projected because of all this process of having to test ourselves and then submit to them and trying to make sure that they were following everything that needed to be configured in order to the connection to work. For example, having the correct certificate stored on Azure B2C, the correct certificate stored on Azure AD that was connected to Azure Key Vault, everything was correct so that we could eliminate everything else from the equation in terms of debugging. So debugging was really a challenging during this project. So reviewing this implementation, so we had a solution based on the OpenID Connect module. We needed to add an authentication using a certificate against the Azure AD Active Directory. And we added also a connection to Azure Key Vault. And that was a new thing for us as well. And we had the certificate and keys location referenced outside the Drupal root folder. Yeah, in terms of feature steps for this case, we need some refactor and linked to the code that was done there. Some things can be optimized. And after that, the idea is to prepare a patch and propose an implementation on the control module for future release. And also to prepare a complete documentation about this implementation that we think that could be useful for other people that want to do something similar to that. As we use the control module, we need to fix that on the composer. in order for that not to update and break this implementation. So we need to fix that for our implementation, for our application, and also have a patch. So every time that, for example, we need some composer to install, this patch would be applied and apply our solution to the contrib module. And that will be all for now. If you have any questions there, just feel free to ask in the chat.